Hello and welcome to 10.5, Area and Arc Length and Polar Coordinates. Theorem 10.13 says area and polar coordinates. If f is continuous and non-negative on the interval from alpha to beta, if theta is less than beta minus alpha, less than 2 pi, so it means that they're within 0 to 2 pi, then the area of the region bounded by the graph of r equals f of theta between the radial lines theta equals alpha and theta equals beta is given by area is 1/2 integral from alpha to beta of f of theta squared d theta, which is just 1/2 integral from a to alpha to beta of r squared d theta. So find the area of the region, one petal of r equals 3 cosine theta. Do that better. Now, one petal of r equals 3 cosine theta is going to just go from 0 to pi. Let's see. Cosine of 0 is 1, so 3 times 1 is 3. It's going to be doing this type of thing. Okay. So we're going to look at the area is 1/2 the integral from 0 to pi of 3 cosine theta squared d theta. That's going to be equal to 1/2 integral from 0 to pi of 9 cosine squared theta d theta. So that's 9/2 integral 0 to pi of cosine squared theta d theta. That's 9/2 integral from 0 to pi of 1 plus cosine 2 theta over 2. That's the power reduction formula. D theta, which is 9/4 now, integral from 0 to pi of 1 plus cosine 2 theta d theta. And that's going to give us 9/4 times theta plus sine 2 theta over 2 from 0 to pi. That's 9/4 times pi plus sine 2 pi over 2 minus 0 plus sine 2 times 0 over 2. Well, the sine part's just going to be 0. Sorry, there's 2. There's a whole thing there. Okay, so the sine part is just 0. So what we have is 9/4 of pi. And that'd be the area of that region. Let's go on to the next one, example 2. It says use a graphing utility to graph the polar equation to find the area of the region, area of the given region, and we're talking about the inner loop of r equals 4 minus 6 sine theta. I think this is a lemicon. Let's take a look. Okay, so here's my calculator, and let's go. I already have in the calculator there. Now my window, if you're curious, I'm going 0 to 2 pi, and that's by pi over 12 or pi over 24. I did my x min and x max negative 7 to 7 with a scaling of 1. Y min is negative 10. Y max is 2. So I graph this, I get this shape. Now we want to know about the inner loop, the area of the inner loop. Now how do we get to the inner loop is one of the questions. So we'll come back to the calculator in a second. I want to do some work first. So this is our shape roughly. So where is it going to be 0? Where is 4 minus 6 sine theta going to be 0? Where's that happening there? That's where 4 equals 6 sine theta. That's where 4/6 is sine theta. That's where 2/3 is sine theta. Or theta is arcsine of 2/3. That occurs, now if we just look at this in terms of a graph here, get this part, arc sine of 2/3, not drawn to scale by the way, and then over here be also the reference angle, arc sine of 2/3. So we want to know what this area is. It's the area between these two locations. We can just find half and multiply it by 2. So we're going to end up going with like 2 times 1/2 the integral from sine inverse of 2/3, or arc sine of 2/3, to pi over 2, because this mark up here is pi over 2, of 4 minus 6 sine theta squared d theta. So we'll put this in the calculator, have it do the work for us. I may have to erase the board, so feel free to pause that, but yeah, I will. I can move it down here maybe. Okay, so we have, go back to home. I tried putting this in before and I had the square in the wrong place. So let's go back up to what we have. Okay. Maybe I should just re-enter the entire thing. So it's integral from sine inverse of 2/3 to pi over 2 of 4 minus 6 sine of theta squared, so the squared applies to all this part, d theta. This is what we come up with. Let me get the decimal approximation. 1.7635191. And that's for half of it. But really we don't have to double it because the 2 and the half cancel out. So this is going to be 1.7635. And that's it for that one. And I accessed this integration by doing F3. F3 gives us calculus tools. I did the integration one. Okay, moving back to lesson. Let's go on to the next page for example 3. Okay, example 3 says find the points of intersection of the graphs of the equation. R equals 3 times 1 plus sine theta, and R equals 3 times 1 minus sine theta. So we have 3 times 1 plus sine theta equals 3 times 1 minus sine theta. So divided by 3, 1 plus sine theta equals 1 minus sine theta. Subtracting 1 from both sides, and you can add sine theta to both sides. 2 sine theta equals 0, so sine theta is 0. So theta must be 0, pi, 2 pi, but I think we're going 0 to 2 pi, not inclusive of the 2 pi. So if we do R equals 3 times 1 plus sine theta, that's going to be 3 times 1 plus 0, which is 3. R equals 3 times 1 minus sine theta, I should say pi, that's 0. That's going to again be 3 times 1 minus 0, which is 3. If we do R equals 3 times 1 plus sine pi, that's 3 times 1 plus 0, which is 3. And R equals 3 times 1 minus sine pi is 3 times 1 minus 0, which is again 3. So we know they intersect at 3 comma pi and 3 comma 0. Now we're going to check for symmetry. replace r by negative r, and replace theta with theta plus pi. So we have r equals 3 times 1 plus sine theta. That means we'll make the substitution. Negative r is 3 times 1 plus sine of theta plus pi. So negative r equals 3 times 1 plus, this is sine of theta, cosine of pi, plus sine of pi, cosine of theta. Now, cosine of pi is negative 1. Sine of pi is 0. So negative r equals 3 times 1 plus sine of theta times negative 1. So negative r equals 3 times 1 minus sine theta. So that r equals negative 3 times 1 minus sine theta. Now we'll set that equal to the other one. So that's negative 3 times 1 minus sine theta equals 3 times 1 minus sine theta. So that's negative of 1 minus sine theta equals 1 minus sine theta. So that negative 1 plus sine theta equals 1 minus sine theta. And if we add 1 to both sides and add sine theta to both sides, we'd have 2 sine theta equals 2, so sine theta equals 1, so theta must be pi over 2. Now if we check that, we find some blank part to finish this problem. There's mostly blank. Okay. So checking theta is pi over 2, r would be equal to 3 times 1 plus sine of pi over 2. That's 3 times 1 plus 1, 3 times 2, which is 6. And r equals 3 times 1 minus sine of pi over 2, which is 3 times 1 minus 1, which is 3 times 0, which is 0. So that would conclude that these are not going to be the same places. So that's not going to be a point of intersection. We're just checking for symmetry for the r. Being here versus being down there and up again. Okay. And you erase this in just a second, so pause it if you need it some more. We're going to go on to example 4. So let's find the length of the curve over the given interval. R equals, I didn't do arc length. Let me go a little further up. There we go. So theorem 10.14, arc length of a polar curve. Let f be a function whose derivative is continuous on the interval from alpha is less than or equal to theta, less than or equal to beta. The length of the graph r equals f of theta from theta equals alpha to theta equals beta is little s, integral from alpha to beta, the square root of f of theta squared plus f prime of theta squared d theta, or the square root of r squared plus dr d theta squared d theta. Give ourselves plenty of space to work here. Find the length of the curve over the given interval. R equals 1 plus sine theta. So r prime would be cosine theta. So S would be the integral from 0 to 2 pi of the square root of 1 plus sine theta squared plus cosine theta squared d theta. This is the integral from 0 to 2 pi of the square root of 1 plus 2 sine theta plus sine squared theta plus cosine squared theta d theta. Now, sine squared theta and cosine squared theta is just 1. So it's going to be equal to 0 to 2 pi square root of 1 plus 2 sine theta plus 1 d theta. That's going to be 2 plus 2 sine theta d theta. We can factor out a 2, so the integral from 0 to 2 pi of the square root of 2 times the square root of 1 plus sine theta d theta. So pull that square root of 2 out, integral from 0 to 2 pi of what? 1 plus sine theta. Now one way to get this out, get this to something we can work with, like a cosine squared or something like that, is to multiply this by the conjugate 1 minus sine theta over the square root of 1 minus sine theta d theta. This is the square root of 2 times the integral from 0 to 2 pi of the square root of 1 minus sine squared theta over the square root of 1 minus sine theta d theta. And that's going to be the square root of 2 times the integral from 0 to 2 pi of the square root of cosine squared theta over the square root of 1 minus sine squared theta, or just sine theta. And what's the nice thing here is the square root of cosine squared is just going to be square root of 2, integral from 0 to 2 pi of cosine theta over the square root of 1 minus sine theta d theta. Now we can try to make this a little easier on ourselves if we do the following. Now we're doing square root of 2 times from 0 to 2 pi, the full region. What if we do half the region? So we can say 2 times the square root of 2. We'll do the region from pi over 2 to 3 pi over 2. Places where sine is going to be 1. That could be helpful, or 1 or negative 1. And then we'll say negative cosine of theta over the square root of 1 minus sine theta d theta, because cosine will be negative in these parts, in these regions. That's the second and third quadrants. Now we have, if we said u was 1 minus sine theta, our du would be negative cosine theta d theta. So we can integrate this. This becomes 2 root 2 times 1 minus sine theta to the 1/2, because it's to the negative 1/2, over the 1/2, from 1/2 to 3 pi over 2. And because we're dividing by 1/2, we can multiply by that 2. And we end up with the square root of 1 minus sine of 3 pi over 2 minus the square root of 1 minus sine of pi over 2. So this is 4 root 2 times what? Square root of 1 minus negative 1 minus the square root of 1 minus 1. So it's 4 root 2 times the square root of 2. That's a 0. That's the square root of 2. So we end up with 8. That was a fun result. So that was the arc length of 1 plus sine theta from 0 to 2 pi. I know this is the trickiest part. We went from 0 to 2 pi to pi over 2, 3 pi over 2. The difference is this is the entire circle. This is half of it, so that's why we say 2 times that. And cosine becomes negative, which fits in well with this derivative here. The d, if our u is 1 minus sine theta, fits in well with the du being negative cosine theta d theta. By choosing those values, we could have said 0 to pi, but then our signs are just going to be 0, and it's not going to be as helpful. By going pi over 2 to 3 pi over 2, we're able to have signs being positive. I mean, it would have worked out the same because you would have had 0, 0 would have been. Anyway, this is, I think, a little bit better way to go. But again, to stress, this became negative because of the region for the integration. Okay, let's go on. Oh, now I want to say we just did arc length, and what do we usually do in this entire semester when we've done arc length in one hand? We do surface of revolution, and that's our next part. Theorem 10.15, area of a surface revolution. Says let f be a function whose derivative is continuous on the interval from theta, the area of the surface formed by revolving the graph r equals f of theta from theta equals alpha to theta equals beta around the indicated line, either the polar axis or theta equals pi over 2, so either the horizontal or the vertical. S equals 2 pi, integral from alpha to beta of f of theta sine theta times the square root of f of theta squared plus f prime of theta squared d theta. That's about the polar axis. And so sine of theta goes with going around the polar axis. We have cosine theta if it goes about the line theta equals pi over 2. Everything else is the same. So for our last problem of this section, find the area of the surface formed by revolving the curve about the given line r equals a cosine theta for theta between 0 and pi over 2 and theta being pi over 2. So it's the second case. Second formula. We'll use a cosine in this one. Our r prime is going to be a times negative sine theta, which is negative a sine theta. So s would be 2 pi integral from 0 to pi over 2 of a cosine theta times cosine theta square root of a cosine theta squared plus negative a sine theta squared d theta. So s would be 2 pi integral from 0 to pi over 2 of a cosine squared theta square root of a squared cosine squared theta plus a squared sine squared theta d theta. Out of this, you can factor on an a squared, so it becomes a squared times cosine squared theta plus sine squared theta. And that should automatically go off in your head now that that is just 1. So we have 2a pi integral from 0 to pi over 2 of cosine squared theta times the square root of a squared times 1 d theta. And that's going to be 2a pi integral from 0 to pi over 2 of a cosine squared theta d theta. So pull that a out as well. So we have 2a squared pi integral from 0 to pi over 2 of cosine squared theta d theta. Now what did we do earlier when we had a cosine squared theta? We did the power reduction formula. So that becomes 2a squared pi integral from 0 to pi over 2 of 1 plus cosine of 2 theta over 2 d theta. And the nice thing is, then this 2 down here would cancel with the 2 out front. So So we end up with a squared pi, integral from 0 to pi over 2, of 1 plus cosine 2 theta, d theta. So now we're ready to integrate. We end up with a squared pi times theta plus sine 2 theta over 2 from 0 to 2 pi. That's going to be a squared pi times what? No, this is pi over 2, not 2 pi. So we have pi over 2 plus sine of 2 times pi over 2 over 2 minus 0 plus sine of 2 times 0 over 2. So it's a squared pi times pi over 2 times sine of 2 times pi over 2, that's sine of pi, that's just 0. So plus 0 minus 0 plus 0. So we end up with a squared times pi over 2, or a squared pi squared over 2. Okay? And that will do it for that section. So send me your questions and I'll see you guys online. Thank you, and I hope you have a good day.